Today, we are pulling back the curtain on the amazing hidden systems that make modern high-rise living even possible. We're talking about the huge power grids and the super smart elevators that work silently right behind the walls. So, let's dive right in.
I mean, really think about it. You flip a light switch, you press a button for the elevator, and it just works. But behind that simple action, there's this massive, complex network that just springs to life. We totally take it for granted, but how does it all actually work?
So, that's what we're going to do. We're going to take a virtual tour of a modern residential tower. We'll trace the path of electricity all the way from the city grid right into your living room, and then we'll jump on the vertical highway, the elevator system, to see the incredible engineering that makes it all safe and efficient.
Okay, first up, power. A tall building is just incredibly power hungry. Getting all that energy from the main grid and then spreading it out safely to hundreds of different apartments, that is a huge engineering puzzle to solve.
So check this out. This is the entire journey. Power comes in from the main grid at a, frankly, staggering 11,000 volts. Way too hot to handle. So the building has its own substation that steps that voltage way down to a much safer 415 volts. From there, a distribution board acts like a traffic cop, telling the power where to go. Now, in a tall building, you can't just run separate wires to every single floor. It would be a complete nightmare of cables. Instead, they use this brilliant system called busbar trunking. Think of it like an electrical superhighway running straight up the core of the building. This one system replaces kilometers of messy wiring, which saves a ton of space and, really importantly, dramatically cuts down the fire risk.
Of course, all that power needs some powerful safety systems. And tucked away behind your walls are a few small but incredibly important devices that are basically watching over you and your stuff 24/7. Let's see how they do it.
Okay, this is really the key thing to get. You've got two different protectors. The MCB, that's the miniature circuit breaker, is like a sentry for your appliances. If you plug in too many things or a device short circuits, pop. It trips to stop your TV from frying or a fire from starting. But the RCCB, the Residual Current Circuit Breaker, well, that's your personal lifeguard. It's designed to detect tiny, dangerous leaks of current, the kind that can cause a serious electric shock, and it cuts the power in milliseconds. It could literally save your life.
And the bedrock of all electrical safety? It's earthing. This is the ultimate failsafe. If, say, a wire comes loose inside your washing machine and touches the metal case, earthing gives that dangerous electricity a super easy, safe path to go directly into the ground, instead of going through you when you touch it. Such a simple concept, but it is absolutely vital.
All right, we've got our power sorted out and safe. Now, how do we get people up and down 20, 30, maybe even 50 floors? It's time to head over to the vertical highway and see how elevators have totally mastered the modern high-rise.
So you've basically got two main players in the elevator game. Hydraulic lifts, which use a giant piston to push the car up, are pretty good for shorter buildings, maybe up to 6 floors. But for the tall towers we're talking about, the undisputed champion is the traction lift. It works with steel cables and a really heavy counterweight, which makes it way faster and much more energy efficient. And a lot of modern ones are what's called MRL, or machine room less. It's a super clever design that tucks the motor right inside the elevator shaft itself, which frees up all this valuable space that used to be taken by a big bulky engine room on the roof.
Now, it's not just about going up and down. It's about doing it safely. And in a lot of places, regulatory bodies like the DDA, the Development Authority, they set some really strict safety rules. So let's look at some of the latest, absolutely non-negotiable features that they now require for residential elevators. This stuff is so important. First off, the ARD, or Automatic Rescue Device, is now mandatory. What does that mean? It means if the power ever goes out while you're in the lift, you won't get trapped. The ARD has its own backup power that automatically moves the lift to the closest floor and opens the doors. Easy. The rules also demand a minimum capacity, special service lifts for taller buildings, and, this is a big one for older buildings, you need a structural certificate and you need consent from 2/3 of the residents before you can even think about putting in a new lift.
Phew, okay, we have covered a lot of ground. And to make sure these key ideas really stick, we're going to do a quick pop quiz. These are the kinds of details that engineers and architects obsess over, pretty similar to what you might find on a technical exam like the DDA or GATE. Let's see what you picked up.
All right, first question. Think back to our safety devices. Which one is the personal lifeguard, the one built specifically to protect you from an electric shock? Go on, have a think.
And yep, the answer is B, the RCCB. Remember, the MCB is the appliance sentry, but the RCCB is the human lifeguard.
Question 2. We just covered this critical safety feature.
What is the main job of the Automatic Rescue Device, or ARD, when the lights go out?
That's right, C. The ARD is your get-out-of-jail-free card during a power failure. Its only job is to get you safely to the nearest floor and open those doors. It's all about safety.
Okay, here's a quick bonus question on a related system. We've been all about elevators, but what about escalators in, say, a big shopping mall? What's the standard angle they're built at?
And the answer is B, 30 degrees. Turns out that's the industry sweet spot. It perfectly balances a comfortable ride with saving as much valuable floor space as possible.
Okay, back to our high-rise. You're the engineer on a new 20-story tower. Which type of elevator are you putting in your plans?
It's gotta be B, the traction lift. No question. Just like we saw in that comparison, they're faster, they're more efficient, and they are built specifically to handle the demands of a really tall building.
All right, last question. Remember that electrical superhighway we were talking about? The one that zips power up the building? What's its official name?
And the answer is B, busbar trunking. That's the name for the electrical superhighway that efficiently shoots massive amounts of power up the entire height of the building. Hey, nice work.
You know, that really is the whole point of all this engineering, isn't it? From that high-voltage power being tamed down in the basement to the heavy counterweights perfectly balancing an elevator 20 stories up. These are incredibly complex systems that are designed to be so reliable that we never even have to think about them. They just work.
So I'll just leave you with this thought. The next time you're in a tall building and you flick a switch or press a floor button, maybe, just maybe, you'll have a brand new appreciation for the incredible, invisible engineering that's happening all around you.